Okay, I forgot to resume my recording. So that one, we can expect to repeat that skill tomorrow on our test. I think you had isometric and isotonic in your review, perhaps. This was a lab that we did in the past. I didn't do it this time because a lot of people, when we did the POGL that we were supposed to measure the bands, they all said they didn't have anything to measure with. And so, though you would think it would be easy enough to get something to measure with, this required a measurement, so I didn't have us do it. But isotonic, so iso means equal. Remember, an isosceles triangle has equal sides. Tonic, tonicity, is referring to pressure, and metric is referring to length. So in an isotonic contraction, there is an equal amount of pressure throughout the movement, but there is change in the length of the muscle. So the length of your bicep, when you lift a load, when you flex a joint, you can, like you yourself can put your fingers on your bicep muscle here from end to end, and then see what happens to that as you bend, right? So it gets shorter. So that would be an isotonic contraction. Any effort that lifts a load and affects a joint will be isotonic. Isometric means equal length. So if you press against a wall and you're straining to press against the wall, you can push harder. You're making more and more effort, more and more pressure, but the length of the muscle will not change. So that's an isometric contraction. In class, I would take somebody's arm and I would press against it and have them press towards me, and they would notice like they can change their effort, but they would not change the length of their muscles. A lot of your stretches you do isometric contractions with to increase the flexibility. And then aerobic and anaerobic, again, this is one that we would have done in class. And in class, I would have you use like a blood pressure cuff and cut off your blood supply. So then you're going to experience an oxygen debt. And you would notice that with the oxygen, with the full blood supply, you would be able to do many more of the exercise, and we would just be like lifting a weight with our fingers. And then once you cut off the blood supply and you limit the amount of oxygen and therefore go into oxygen debt and muscle fatigue, you would notice you wouldn't be able to lift as many. And so that's the connection between those two. Aerobic will go longer with oxygen, anaerobic shorter without oxygen. We did talk a little bit about actually anaerobic and aerobic when we talked about the red and white muscle fibers, the fast and slow twitch muscle fibers. We talked about the red twitch are the aerobics, and so they can resist muscle fatigue. And the anaerobic are your white twitch muscle fibers, more likely sprinting and power efforts. And they are utilizing the anaerobic system, and so they're going to tire more quickly, more easily. So we did talk about that. In that same lab, we would have done some hand clenches, and when our hands were warm, we would notice we were able to do it much more quickly than when we put our hand in a cup of ice water for a minute, and then we wouldn't be able to contract as quickly. And the reason that is happening is really because of diffusion's effect, or like the temperature's effect on diffusion. So molecules move more slowly overall in cooler temperatures. So if you think about the fact that acetylcholine has to cross a gap, right? Sodium has to diffuse into a cell. Calcium has to diffuse out of the sarcoplasmic membrane and bind with troponin. All of those are diffusing molecules, right? So anything that affects the rate of diffusion affects your movements. So you probably have recognized this yourself in the winter when you're outside and like you try to close your hands or you try to do something and it's just not as easy. And if you're in any type of sports, you notice after you warm up, you do some kind of warm up before your exercise or your sport, you have like faster reflexes, right? You can move more quickly. And it's all like that warming of the body is increasing the rate of diffusion, letting the muscles and the nerve cells talk together at a quicker pace. Kind of like when I get on a roll, I talk really fast. So that's the idea behind temperature's effect on the movement of molecules. Okay, so I'm going to go back. That's something I meant to clarify the other day. So I wanted to take specific questions from you guys rather than just going through the whole review, which I could, but I want to clear up the things that you're struggling with. And at the same time, just point out a couple things. Today's points are some practice questions. So in Google Classroom, you'll find a Wiser Me, and it is muscle groups, not that one. It's muscle groups and actions. Muscle groups and actions. So that's going to be today's points. I think there might be 15 questions. Mr. Confer, did you make that one?
I think so. Yeah. Yep.
Yes, Mr. Confer made this one for us. And then, so this is the one thing I need you to turn in. All the rest of this is just there to use or don't use as you will. So you have a Jeopardy game that you could play. If we were in class, maybe we'd play it. Just resource sheet reminding you of how muscle organization is broken down. Ever-growing vocabulary list. Each of these words, you should know what they are. I have a whole folder of Quizlets for muscle system. I think the most complete one is maybe 54 questions. So that's a good one to use for an overall review. I have a quiz, a Kahoot that you can play for practice for the fun of it. And here's websites. If you have specific items that you're struggling with, you can open this website up and then those, or that document up, and the websites are by topic. A lot of people struggle with the sliding filament theory. On the test, I will have a sequencing question. It's 7 points, and you have to put each of the steps into the proper sequence. So if you get one wrong, it might offset the rest of your sequence, right? So that's a good document to study. What does Ms. Snook see as the sequence? And then finally, the anatomy in class review, which I linked to each of your reviews after you turned them in. So you could go through that. This is the one system that I don't have a video review for. I don't know why, but I guess I just always get busy right about this time because I think I'm going to make a new one and I don't. So I can go through specific questions from the review if you would like me to explain something a little bit better, a little bit more detail. I can talk to you about your test. What would you like me to do for you? What would you find helpful right now? We're going to be informal today because there's just 4 of you. I could quiz you.
Didn't you say that we had to know how to do the lad snore thing?
Yep, that's another one. So lad snore, are you able to tell me what each letter stands for?
And then does it matter which muscles we give as an example?
Nope, as long as it's correct. So if you said location and you gave me sartorius, I'm not sure that tells me where it's found, right? So your location example has to be one that does tell me where it's found, biceps brachii, rectus femoris, rectus abdominis, tibialis anterior. Any of those would be fine. I'm going to have to read each of your individual answers and approve them because we might not all use the same examples.
You just have to do it for all the muscles or just one time?
So this particular question, you have to give an example for each letter of lad snore. So you'd have to, you would form your question, your answer like this. L is location. right? So what's a good location muscle? I gave you some.
Tibialis anterior.
Thanks. Since there's just a few of us, let's all talk. Tibialis anterior. So I'm writing this down myself. So A is action. So we've only named a few that have to do with action. We have flexor digitorum, extensor digitorum, flexor carpes. I would say masseter is even an action because it's mastication. We didn't name any of the adductors or abductors. We just named some specific flexors and extensors. So I would give me one from the forearm. So I wrote action and then pick one of those flexors or extensors and then digitorum or carpi.
Like flexor digitorum, did you say?
Yeah, that's good. LAD, direction of fiber. And I need to spell out that whole thing, direction of fiber. And then we talked rectus, transverse, obliques, and orbicularis. Those were all directions. So you can pick one of those, rectus abdominis, rectus femoris, external oblique, orbicularis oris, orbicularis oculi, any of those. So write one of those down. So S is shape. The most common examples are deltoid and trapezius. I think platysma might be considered a shape name because plat is flat. Latissimus is referring to broad. Deltoid and trapezius are the most common examples. N is your number of origin. So we've mentioned biceps brachii, biceps femoris, triceps brachii, quadriceps femoris. Any of those would work. So write one of those down. O is a little bit longer, origin and insertion. Not just origin, but origin and insertion. And we have named two, brachioradialis and sternocleidomastoid. Those are really the only two that we talked about in class. So either brachioradialis or sternocleidomastoid, whichever is easier for you. And the final letter R is for relative size. So within a group. So ones we mentioned, pectoralis major. There's also pectoralis minor, gluteus maximus, gluteus minimus, gluteus medius. There's zygomaticus major and zygomaticus minor, although we only did zygomaticus, so we didn't really differentiate. So I would go with a glute or a pec. But not just the word glute. You would need the whole gluteus maximus to identify relative size. Okay. Are you good on lad snore?
Yeah, thank you.
Okay, and then maybe should I delete the isometric isotonic question since we technically didn't talk about it in class? Probably. So then we did the sarcomere and its labelings and what's happening. The sequence of events for sliding filaments. Do you want to go over that?
Yeah, sounds good.
Okay. So there has to be an action potential on the nerve first, right? The motor neuron. So I'm writing this down to keep myself from going too fast. And that happens because of calcium, though I'm not using that in my answer or in my choices. Acetylcholine is released. ACH for short. Acetylcholine is released. The acetylcholine binds sarcolemma. At the receptor sites. I think I might like to change the wording of that one. So that allows the membrane to be permeable to sodium. Sodium rushes in. And the action potential is initiated. The action potential propagates or spreads. Hey, was UPS just at my house? APO propagates, which causes calcium to be released from the sarcoplasmic reticulum. Calcium released from, I'm just going to write SR. I know that means sarcoplasmic reticulum. So once the calcium is out, notice how like a lot of these, the end of one statement is kind of the beginning of the next statement because every step is cause and effect, right? So calcium binds troponin. Troponin changes shape. Myosin binds actin. Actin slides past myosin. So I made that into a 12-step process, and I think I have 8 steps. So a couple of those will be eliminated. Just make sure I know what time my next class starts. 10:42 is our okay, good advisory. Okay, so that's LAD snore. So that's going to be 8 points. Are you good with that? Do you need me to repeat any of that? Oh, I'm using my PC mouse trying to manipulate this. So this document here will have that step by step. It just doesn't say 1, 2, 3, 4, 5, but pretty much what you just wrote down is the steps that you will find here, along with a couple pictures to help you understand what's happening. Edit, undo, that's your relaxation phase. So basically you start at the end and you just reverse everything. So I like that one. You got a matching using like characteristics of muscles, like contractility, elasticity, irritability. I might have to edit this one because I also included lactic acid, which would have went with your anaerobic, and we didn't do that one. I do have slow twitch and fast twitch muscle fibers. And then I had tetanus, but we haven't talked about tetanus. Tetanus is when your muscles remain contracted, right? You get a tetanus shot because that bacteria causes the muscles to remain contracted. But a cramp, you've probably all experienced a cramp. That is a tetanic contraction. So that's when muscle, like the contractions are so close together that they just fuse into one long contraction. So I think I'll probably have to edit my matching and try to come up with some new words. But definitely characteristics and the different types of fibers. You know what would be good to put there? Organization of muscles. Do you need help with any of the paramycium, epimycium, any of those? Fibers, fascicles, fibrils? Is that for me, Jordan? So let's pull this one up. So remember, epi means above or upon. So as far as your EMs, epi is the outermost, peri is the middle, and endo is the innermost. Epi, peri, endo. Those are all connective tissues. The myo tells you it's muscle. EM tells you it's a tissue. And epi just tells you where it's found, right? Or the prefix, epi, peri, or endo. So you have the whole muscle surrounded by the epimycium, so the outer tissue. Inside, you have a bunch of fibers that are bundled together. So in here, all of these individuals are fascicles, right? The fascicle is a bundle of fibers. It is surrounded by the paramycium. So this white tissue you see here is the paramycium. Inside the fascicle are individual fibers. So here, this fascicle has lots of fibers. Here's one that we're pulling out. So this one fiber has an outer covering, the endomycium. And then I can take that one fiber apart and pull out fibrils. The fibrils are where you find your actin and myosin. Actin and myosin are myofilaments. So they make up your sarcomeres. So you have muscle, fascicle, fiber, fibril, filament. A lot of F's. Maybe this would be a good kind of picture to put on for labeling, because we spent a little bit of time on this one. Label of organization. We didn't do a face labeling quiz. I should probably add that, shouldn't I? Okay, so then muscle actions. I have a matching that has to do with muscle actions. So like flexion, but it would be description, right? So decreasing an angle at a joint, increasing an angle at a joint, right? Movement about an axis is going to be a rotation. We have our plantar flexion, pointing the toe, our dorsal flexion, pulling it back. Inversion, the soles of the foot go inward. Eversion, they go outward. We talked about supination, holding the bowl. Pronation. Supination, palm up, pronation, down. Abduction and adduction. Ab, taking it away from the midline. Add, bringing it toward the midline. Huh. I already do have a matching for the organization.
Did you say that abduction is bringing it towards the midline?
ADD?
Yeah.
Yep. So
Okay.
think you're adding it to the body.
Okay, gotcha. Thank you.
Yep, when something is abducted, it's taken away, right? So bringing your legs out for the jumping jack would be an abduction. Everything's abducted. And when you come back to the center is an adduction. Okay, so I already have that matching actually. So then there's a matching already made for the different components of the organization. Remember, sarcoplasm is the cytoplasm of the muscle cell. Sarcolemma is the membrane. Those are two that I didn't say earlier. You have the word association, like putting them into groups, you have to eliminate one of the words. So like, if you had a 10-mile jog, a 100-meter dash, a 50-meter swim, which is short, a powerlifting, which is quick and short, and long jump, which is quick and short, which word would not belong? So 4 out of the 5 were quick and short. So you'd pick the one that took you a little longer to complete, right? If I put marathon in there, you'd pick marathon. So you have a handful of those. Muscles, I could say like frontalis, zygomaticus, temporalis, sartorius. Which one doesn't belong? So I gave you 4 muscles of the face and 1 of the leg. So you'd pick one from the leg, right? So I maybe have abilities, our characteristics, and maybe one word is like a type of fiber. And so you would pick the one that doesn't belong to the group. So that's where, if you look at your ever-growing vocabulary list, all of those words I've put into chunks, right? So that's a good one to help you prepare for the word elimination questions, because you're going to pick the word that isn't in that chunk, basically. Okay. So then 34 of the questions are multiple choice. There are 3 that you have to identify the pictures. So which one is the cardiac tissue? Which one is the skeletal tissue? Which one is the smooth tissue? Do you need to look at those again?
We have to do what we did in the review and like label like the nucleus.
You're not going to label them. You're just going to identify which of the 3 types of muscles they are.
Okay.
Okay. And you guys did that in your interactive notebook, right? So stripes, obvious stripes is skeletal. If it looks, to me, I describe it as ribbony because it's thick on the inside and then thins out. That's your smooth. And like distinct jagged lines every here and there, that would be cardiac because they have that intercalated disc. So the rest of the muscles are mostly related to muscle actions. The rest of the questions. So, like, which muscle draws your lip downward? This is what I'm going to be doing when you take your test. You guys know it. That would be the platysma. What about like a kicking action? What muscle is going to be responsible for that? So which one straightens your legs? That's going to be the rectus femoris, Miss Snook. You're right. Yes. So there's a lot of those types of questions. There's also some that are like origin and insertion, a commonly missed question I told you the other day was the frontalis. It does not originate on the frontal bone. It covers the frontal bone. It originates on the aponeurosis, right? The aponeurosis, the cranial aponeurosis, the white tissue on the top of the head. Commonly missed question. Locations of like, where would you find cardiac tissue? Where would you find skeletal tissue? Where would you find smooth tissue? Do you have any questions on any of those? No. Other origin insertion questions are kind of generic. Like if the muscle moves the upper arm, what bone does it insert on? So remember, action occurs at the insertion. So whatever's moving, you don't have to have it memorized. Whatever's moving, that's the insertion. And the origin is going to be above that point, like above the joint. So if you're flexing the forearm, the origin has to be above, the insertion has to be below. If I were going to move my leg out to the side, that's a hip movement. So the origin has to be above, so maybe on my ilium, and the insertion has to be below, so on your femur. If you're moving your knee joint, the origin is above the femur, and the insertion is below tibia. So you don't have to have that memorized if you just recognize the origin is distal to the joint, and the insertion is, the origin is proximal to the joint, and the insertion is distal to the joint. And mostly our actions occur by pulling on the distal attachment. Okay. I would go through all of the muscles we've named. Maybe go back through the, your muscle PowerPoints, or just this ever-growing vocabulary list. Am I sharing? Yes, I am. Be able to tell me what each of these muscles do, because that's probably the bulk of the multiple choice questions. Is just based on actions. Knowing terms like antagonistic and synergistic. Antagonistic, remember, is opposite actions, so a flexor and an extender, biceps brachii, triceps brachii. Synergists work together in synergy. That's the whole idea of synergy. They work together in unison. So synergists create the same movement. Gastrocnemius and soleus. They're synergistic. Brachioradialis and biceps brachii are synergist. So the terms antagonist, synergist, and prime mover. That's the one mostly responsible for the action. I think that about covers it without going through every individual one, but you guys can do that on your own, right? So what could I clear up that I haven't already before we go celebrate Veterans Day in our advisory? Do you guys go to your advisory class? Good. Zach, can I answer any of your questions?
I think I'm good. I think I'm gonna ace it. No, I'm not.
Yes, good. Rafi, any questions I can answer for you?
No, I think you covered everything.
Good. This, too bad you're gonna miss this, Mr. Cofer. This is a fun test to watch kids take, or confer. Because, you know, when you're thinking it through, and I might not see as much as I do in person, but in class, it's fun to watch them because they don't even realize that they're like doing all kinds of actions. It's good fun.
Yeah, even in just when we're doing facial muscles, it's fun to just.
Yeah. I liked the activity that I had them do this time. I wish I would have done it with the other muscle lectures too. They had to make a facial expression chart with their own pictures, and it was really fun to look at them. For me, it was fun. And Addie included video so I could tell the difference between the chewing muscles. That was good. Okay, well, if you guys don't need me for anything, I'll go open up my next Zoom. So don't forget, just today's points are, that's the only thing maybe I leave you with. Today's points is that multiple choice. You might see some similar questions on your test. Wherever that went, the wiser me, but not that one. But it's in there. Muscle groups and actions. Okay. So if you need me, stick around for a sec. If not, you guys are free to go.